Now we're going to switch gears a little bit, and I'm going to talk about one-sided limits. Previous examples all showed us as you were on either side of the target point in question, the graph was approaching the non-point, or the point, whichever the case may be, from both sides. Now I want to show you an example of a function whose limit is broken more than just having a hole. So let's use this as our example. Recall that's the limit is x goes to 3, x squared minus 9 over the absolute value of x minus 3. Okay, first, of course, we want to put it into y1. So don't forget your parentheses around the x squared minus 9 part. End the parenthesis. Divide. Now to find the absolute value, go into the math button. Move your cursor 1 to the right to get to num, and you see 1 is abs. And you can see it puts the absolute value symbols there. So I'll put my x minus 3. And then like I normally do, let me just do zoom 6 to get a graph right off the bat. Okay, so you can see that it's two pieces like that. It's broken, severely broken. I have found a new way to copy these things now where I can just copy off the screen. And just paste it in. I want to take a look at this graph in some more detail. This graph consists of two lines. You've got a line with a negative slope that ends when x equals 3 or thereabouts. And then you've got a line with a positive slope that comes in from the opposite direction, to the right, if you will, of x equal to 3. So I'm putting holes at the end of each of these lines because the function's not defined when x equals to 3. So I'm looking at two pieces here, a piece on the left and a piece on the right. There's no single limit because these 2 points, 6 and negative 6, or these two values, 6 and negative 6, are not the same thing. So anyways, if you look at the piece of the graph that's to the left of 3, or at least the x values corresponding to the left of 3, you can see that that line associated with that side of it is going to negative 6. So we don't write the limit equals negative 6. What we end up writing is the limit x goes to 3, but now we put a little minus sign in the exponent. So 3 to the minus over of x squared minus 9 over the absolute value of x minus 3. So that little minus is an indication that it's coming from the left side of the target value. Of course, then we can talk about the other side as well. As x goes to 3 from the right, that piece of graph was heading towards a y value of positive 6. The way we write this notation, now instead of a minus in the exponent for the 3, we would put a little plus sign. And the limit as x goes to 3 to the plus, I guess you could say it that way, x squared minus 9 divided by the absolute value of x minus 3 is 6. The rule with limits is that they have to have the left and right limits be the same in order for the limit to be considered to exist. In the case that I have here, since it's broken, two different pieces. As you come from the left, you go to negative 6. As you come from the right, you go to positive 6. That tells me that the limit does not exist, just the straight up limit. This is how we write it. So now I have limit as x goes to 3, just plain old 3. And I simply write dne does not exist. So let me see if I can clarify a little bit on this left and right. That causes left and right, for some reason, students of math, at least a lot of the students that I had, left and right cause a lot of difficulties. You must know which side is left and which side is right. I'm sorry. You also got to know up and down. But let me go ahead and mark off my 3 again, that the x values are approaching. And then look, think about walking along the x-axis on the left side of x equal to 3. That's the part that I'm saying is going to 3 to the minus from the left. Then if you look at the corresponding y values that go with those x values, they are converging, if you will, or moving towards y equals -6. And the same goes for the right side. On the right side of x equal 3, the x goes to 3 plus. If you look at the x values coming backwards towards 3, and then look at the y values that are associated with it, or the graph, if you will, that's trying to get to 6. So the graphs that I had before with just a hole, those limits existed, but the definition in general is that a limit, the limit as x goes to 3 would exist if the left and right limits were the same. Unfortunately, in this particular case, we do not have the left and right limits being the same. So if you were asked simply for the answer to the limit of this, you simply say dne does not exist.